Today we're going to go through the Unit 6 test review, and we're just going to work straight through it. So if any of these you weren't sure how to do, make sure you watch those pieces of this video. If you got them right, then you're welcome to skip over it or watch just to reinforce that. So let's go ahead and get started. All right, for 1 and 2, we want to state if the polygons are similar. Remember, to be similar, they have to have congruent corresponding angles. And on this one, you can see those two angles go together. They're congruent. These two are congruent. Now, all 4 of those are actually congruent, and that's fine. Doesn't have to be the case. See, these 2 angles are congruent, and then those 2 angles are congruent. So we're good on the angles. I'm going to erase that so we can see the numbers well enough. So now we need to check the sides. And so we want to pair up 10 and 25 and then reduce that fraction. So 10 over 25 is 2/5. We do 16 over 40. That also reduces to 2/5. And then for the other two, since they're the same, we only need to do it once. So 6.8 over 17. Now that's not a normal fraction. So let me pull up the calculator just to remind you how to do stuff like this. For fractions, you want to do top divided by bottom. So 6.8 divided by 17. And you can go ahead and click enter and get a decimal. You don't have to. The thing to change it to a fraction is on the math menu. So click math, and this first option is change to a fraction. So math, enter, enter, and you can see this also gives us 2/5. So our angles were congruent, our sides are all proportional, and so we know that yes, these are similar. For number 2, our angles all match up. I'm not going to go through and check them all again. They're almost the exact same angles. But we do need to check our sides. So we have 4 over 11. And that one does not reduce. It just stays at 4/11. Then we've got 6 over 18. Well, if you try to reduce 6 over 18, then you are going to get not 4/11. You are going to get 1/3. So those two are not the same. I'm going to redo this with a different color. Those two are not the same. So we don't need to go any further. We can stop right there and say that these are not similar. Or you can just write no. All right, for 3 and 4, this tells us that these are similar. So we already know that. What we need to do is figure out what the scale factor is. And that's just always setting up our fraction and reducing it. Now this says from the smaller to the larger, so we would always want the smaller number on top. If you did this upside down and got a larger number than 1, that's okay as long as your numbers still match up. I'm still going to count it right. So in this case, for number 3, we would have 4 over 16 or 6 over 24. It does not matter which sides you use as long as you've got a value from both shapes. Either of those reduce to 1/4. If you had it upside down and you did like 24 over 6, that would reduce to 4. And so if you wrote 4, that would be acceptable. I would totally be okay with that. On number 4, here we've got these two. We don't have anything that goes with the 35. We would need this side right here. So we can't use the 35. And we don't have anything that goes with the 21 because we would need that side. So we're stuck using the 30 and the 18. So let's do 18 over 30. 18 divided by 30. Remember, top divided by bottom. And I'm not even going to click enter. I'm just going to go straight to math. Enter, enter. And so notice this reduces to 3/5. Or, again, you could have that upside down. If you said 5/3, that would be totally acceptable to me. For our next two, we're told they're similar again. Now we're trying to find a missing length. This is when we have to start setting up proportions. So we find two that go together. Let's start with the one that has the missing side. So that question mark goes with the 14. So we know we have x over 14. And then we could use the 6 and the 3, or we could use the 10 and the 5. Doesn't matter as long as we have it from both shapes. So I'll use the 6 and the 3. X was on top, so 3 needs to be on top. Make sure you're pairing them up correctly. Since this was on top, this needs to be on top. So the values from one shape always need to be in the same position. So we want to cross multiply. That's how we solve proportions. So we get 6 times x equals 3 times 14. 3 times 14 is 42. And then we want to divide both sides by 6. So our missing side is 7. For number 6, here we've got our x and 48. And then the only option we have for the other fraction is 30 over 36, because we can't use the 25, we can't use the 28. So we'll do 30 over 36. Again, 30 goes on top because the x was on top. So let's cross multiply. We get 36x equals 48 times 30. 48 times 30 is 1,440. Then we'll divide both sides by 36. So x equals 40, or our missing side is 40. 7 and 8, we start them out the same way. We set up our proportions, only this time instead of a single x, we have an algebraic expression. But it's set up the same way. We start the process the same way. The difference is we will have to distribute instead of just multiplying like 6 times x in the last example. So the 2x minus 12 and the 18 go together. And then the 8 and the 12 go together. Now you could reduce 8 over 12 first. It's going to give you smaller numbers to work with, but it also gives you an extra step that could result in an error. So it's up to you whether you want to do that. We'd still get the same answer in the end. So we're going to cross multiply. So we get 12 times 2x minus 12 equals 18 times 8. So this is where we have to distribute. This is where it's different. So we've got 12 times 2x, that's 24x. We've got 12 times negative 12, that's minus 144. And then we've got 18 times 8, which is 144. Now that we've got that done, it's just an algebra problem like we've been doing all along, like you did a good bit of the time last year. We'll add 144 to both sides. So 24x equals 288. And then we'll divide both sides by 24. So x is equal to 12. For number 8, x minus 5 and 3 go together. And then we could either do 4 and 8 or 6 and 12. Doesn't matter which one, we're going to get the same result either way. I'm going to use 4 and 8, and I started to set up my fraction backwards. I need the 8 on top because the 8 is from the same shape as the x minus 5. Then I'm going to cross multiply just like we did before. 4 times x minus 5 equals 3 times 8. Distribute that out. 4 times x is 4x. 4 times negative 5 is negative 20. 3 times 8 is 24. We'll add 24 to both sides. So 4x, we will add 20 to both sides. So 4x equals 44. Divide by 4, so x is 11 on that one. So 5, 6, 7, and 8 all start out the same way. They're the same process. Set up your proportion, cross multiply. 7 and 8 just required a little bit more algebra work. For 9 and 10, we want to state if these are similar. If they are, we want to give a reason. Oh, that's not just 9 and 10, that's 9 through 12. That's all 4 of these. So on number 9, we're given sides. We're given all the sides. We are not told any angles. So if you aren't given any congruent angles or any angle measures, you can't have angle, angle. You can't have side, angle, side, unless you have some vertical angles in there. And then technically you're given those angles. So when we're given all the sides like this, we only have 2 options, either side, 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 or they're not similar. So we need to match these up and see if all our sides are proportional. This is just like what we did way back in these first 2 problems. We want to match our sides up and see if they are proportional. So in the top triangle, 60 is the longest side. And you can see that's KM, so that's the first and last letter. On the bottom triangle, 12 is the longest side, and that's CE. It's the first and the last letter. So 12 over 60, that's going to reduce to 1 over 5. You are more than welcome to use your calculator to reduce these. Our next one, ML, that's our middle side. And CD, that's our middle side. We want to match those up. 11 over 55, that also reduces to 1/5. And then LK and DE, those are our shortest sides. That's 7 over 35, and that reduces to 1/5. So yes, these are similar by side, 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 similarity. On number 10, now we've got 2 angles from each triangle, but we are shown that, let's see here, F needs to be congruent to R for this to work. That is possible. F could be congruent to R, but we don't know. S and E need to be congruent, and here's our problem. S and E, we are told are not congruent. Okay, S has 3 marks. E has 2 marks, so we're told those are not congruent, and that means these are not similar. If you just write no, that would be sufficient. For number 11, we've got 1 pair of angles here. We're given no side lengths. If you aren't given any side lengths, angle, angle, and not similar are your only options. So you have to be given side lengths to use side, angle, side, or side, side, side. Like we can assume something about some angles with parallel lines and vertical angles, but we can't ever assume the sides unless we are given measures. So we've got 1 pair of angles here, and we've got some vertical angles, so we know that those 2 angles are congruent. And that's all we need if we have 2 pairs of congruent angles, using angle, angle, similarity. And then for number 12, we're given 2 pairs of sides, and we see our vertical angles just like in number 11. So we have our angles, we've got sides, but we need to check to make sure they are proportional. Before we do that though, are the angles included angles? Are those between the sides we're given? And yes, they are, because that angle is made up of those 2 sides. This angle is made up of those 2 sides. So that means we have the included angles, so we can actually do the work. This is when you need to look at whether you're dealing with a longer leg or a shorter leg. So 36 is the longer leg between 36 and 21. You have to pair it up with the longer leg of the other triangle. So 36 and 60 have to go together. 36 over 60, that's going to reduce to 3/5. Again, use your calculator to do that. And then we'll pair up 21 and 35. And that is also going to reduce to 3/5. So that means that these are proportional. because their scale factor is the same. So we've got two angles, or excuse me, one pair of congruent angles, and we've got two pair of corresponding congruent sides. So this will be SAS similarity. For 13 and 14, we're told they're similar, and we're back to needing to find a missing side, just like how we did it earlier, only now we're kind of focused more on triangles rather than just polygons in general. Now, the side we're missing is VW in number 13. So VW has to correspond to KJ. So VW are the second and third letters, K and J are the second and third letters. Those have to go together. So that would be 88. So we've got X over 88, and then VU or UV and LK have to go together. So that will be 9 over 72. And now we're ready to cross multiply. Again, you could reduce 9 over 72. That's 1 over 8. It'll give you smaller numbers to work with. So we've got 72x equals 792. I'm not that smart. I've already worked these out. Then we divide both sides by 72. So x is going to equal 11, or our missing side is 11. On number 14, our missing side is EG. That's the first and last letter, so it's got to go with JL. So x over 20 equals, here we've got FE 98. That's going to go with JK, which is 28, so 98 over 28. Let's cross multiply. 28x equals 20 times 98, which is 1,960. Then we'll divide both sides by 28. So our missing side is 70. Our next two, again, same process, only now we've got a little bit more algebra to work through. So LC are the first and second letters, so it's got to go with LM. So we've got 4x minus 7 over 63. And then we'll have 55 over 77. Cross multiply. 77 times 4x minus 7 equals 63 times 55. 77 times 4x is 308x. 77 times 7 is 539. And then 63 times 55 is 3,465. We'll add 539 to both sides. That's going to give us 4,004. And then the last thing we'll do is divide by 308. So x equals 13. So same process, just a little bit more algebra. Number 16. CB has to go with LM. So CB is going to go over the 132. 9x plus 3 over 132. And then 56 over 154. And we're ready to cross multiply. 154 times 9x plus 3 equals 132 times 56. I had to split that up on two lines just because I'm running out of space. So that's going to give us 1,386x plus 462 equals 7,392. We'll subtract 462 from both sides. So 1386x equals 6930. Divide both sides by 1386. So x equals 5. For 17 and 18, we're still solving for x, but now we know we're dealing with midpoints and mid-segments. So because QR is a mid-segment, we know that 2 times QR equals x plus 6, or x plus 6 equals, or excuse me, x minus 1 equals half of x plus 6. It's usually easier if we do the 2 times just because we don't have fractions. So I'm going to write that statement out. 2 times QR equals WY. So that'll be 2 times x minus 1 equals x plus 6. We'll distribute out. That's 2x minus 2 equals x plus 6. Get all our x's on one side. So we have x minus 2 equals 6. I just subtracted 1x from both sides. And now I will add 2 to both sides. So x equals 8. On number 18, same setup. In fact, no, the letters are different. This time it's 2 times QR equals WU. So that's 2 times x plus 13 equals x plus 20. Distribute out. 2 times x is x. 2 times 13 is 26. Our x plus 20 stays the same. Subtract 1x from both sides. So we get x plus 26 equals 20. Subtract 26 from both sides. So x equals negative 6. For 19 and 20, we'll start off doing the same exact thing, but in these, once we find x, we need to go back and find one of our segments, the total length of that segment. So 2 times x plus 21 equals x plus 32. Distribute out. 2 times x is x. 2 times 21 is 42. Subtract x from both sides, so we get x plus 42 equals 32. Subtract 42 from both sides, so x equals negative 10. We want to find EF. So EF equals negative 10 plus 21. EF equals 11. Number 20, same exact thing. 2 times negative 11 plus 2x equals 2x minus 8. So that will be negative 22 plus 4x equals 2x minus 8. Now in this case, our constant came before our x term, and that's fine. It doesn't matter. If you want to rewrite that as 4x minus 22, you can, but you don't have to. That is totally up to you. We will subtract 2x from both sides. So we get negative 22 plus 2x equals negative 8. Then we'll add 22 to both sides because it's a negative 22. Negative 8 plus 22 is 14. So 2x equals 14. Then we'll divide both sides by 2. So x is 7, but that's not our answer. We're told to find ji. Let me change colors there. Okay, so ji equals negative 11 plus 2 times 7. So that will be negative 11 plus 14. So ji equals 3. All right, last 4, we're just trying to find the missing side. These use our side splitter theorem. So here we've got x over 4 equals 1 over 2, and we're just cross multiplying. So 2x equals 4, divide both sides by 2, x equals 2. So our missing piece is 2. Number 22, same thing, x over 10 equals 12 over 8. I used the 12 on top because the x and the 12 are in the same position on their corresponding sides. Cross multiply, so we've got 8x equals 10 times 12 is 120. And then we want to divide both sides by 8. That's going to give us 15. (23) and 24. This is the offshoot of the side splitter theorem, and it really is the same thing, that the pieces are set up as proportions. In this case, instead of a triangle though, we just have 3 parallel lines. So we still have x over 9 equals 8 over 6. And we're going to work it the same way. Cross multiply. 6x equals 9 times 8 is 72. Divide both sides by 6. So x equals 12. And then on the last one, we've got x over 10 equals 4 over 5. So we get 5x equals 4 times 10 is 40. Divide both sides by 5, so x equals 8. So there you go. That's it for our unit review. So make sure you look over these, study them, make sure you know all our different concepts, and get ready for your unit test. Good luck.